Dear friends and followers, welcome back to my channel, and today we'll be looking at this picture in more detail. Why do airplanes have a split rudder and others don't have this unique feature, and an incident with this rudder system. And I'll show you which plane has the coolest split rudder of all. So let's get started.
Velocity 552, the wind is 260 degrees, 3 knots, tail wind 1, runway 16 right, clear to land.
Runway 16 right, clear to land, velocity 552.
Remember the last time you sat at the gate and an Airbus A380 or a Boeing 747 taxied by and you spotted this. Now what you see here is the so-called split rudder, and obviously there is a reason why it's split in two. Now, but before we look at the rudder, we have to get a better understanding of the hydraulic layout of planes, in particular the Boeing 747. The primary flight controls such as the ailerons, elevator and rudder are hydraulically powered. Now in case of the Boeing 747, which has 4 independent hydraulic systems, 1, 2, 3 and 4, are each powered and pressurized by its respective engine. Now if we look at this schematic, you see that the tail fin rudder, or the vertical stabilizer, is split into the upper and lower rudder. Now the upper rudder is deflected to either side by 3 actuators. 2 of them are powered by hydraulic system number 3 and 1 by system number 1. Now the lower rudder comes with 2 actuators, one powered by system number 2 and the other by system number 4. Now as you apply force into the rudder pedals to either side, both the upper and lower rudder will deflect simultaneously towards the given input. Now I'm sure many of you have steered a little boat before, and you might remember as you were maneuvering the boat into a harbour or mooring position, you need a lot of rudder deflection to actually steer the boat. Now because the inputs are less effective due to the low speed, and similar physics apply to airplanes. The slower you fly, the more deflection you need on the rudder to have an effect, and the faster you fly, the less deflection you need. So for example, as she comes in for landing, if the pilots apply full left or right rudder, it will go to the maximum deflection of 31.5 degrees, which sometimes can be necessary in strong crosswind conditions. Now during cruise or speeds beyond 350 knots, with the same amount of input into the pedals, the rudder will only deflect 7.6 degrees and less to either side. But as an airline pilot, you always expect the same reply of your plane, no matter the speed. And therefore, airplane engineers have fitted the flight control system with a so-called rudder ratio changer. Now the general purpose of the rudder ratio changer is gradually reduce the surface deflection of the rudder by the pedals with increasing airspeed. Now please do not mistake this with the yaw damper, that's a whole nother system and video. But to be fair, you barely use the rudder during cruise flight except in non-normal situations like engine failures, etc. But in case you need to center the slip skid indicator, which shows if your plane is yawing to either side, for instance due to unbalanced loading, you can use the rudder trim to even out the yaw, which saves power and fuel. Now if we quickly take a look at the Airbus A380, she has a very similar system. But one thing I can't really wrap my head around is why the Airbus A380 rudder sometimes points in either direction when being parked at the gate position. I did a whole video on that subject as the rudder is being deflected by the wind, but how can the A380 lower rudder point to the left and the upper rudder point to the right? It makes no sense to me. Please comment below if you know the answer to that question. But that still doesn't answer the question of why they are split in the first place. Now let's say hydraulic system number 1 would fail for some reason. Now not yet to worry about the rudder, as we still have system number 3 powering the 2 other actuators. Now let's say the situation is becoming even worse and system number 3 fails also. Trust me, if that were to happen, you are really having a bad day, as all hydraulic systems also have a backup feature. So it is very unlikely, but let's imagine the worst case scenario, meaning you have now lost complete control over the upper rudder. So if it weren't for the split rudder, hydraulic system 2 and 4 backing up the lower rudder, you would have no more rudder authority, which would make your landing very hazardous in case you've had engine failures leading to the hydraulic system losses, for example. So you see, the primary reason for the split rudder, as ever so often, is redundancy. And the rudder isn't the only flight control which has a backup. The horizontal stabilizer comes also with an inboard and outboard elevators, so technically they are also split, and so are the inboard and outboard ailerons. Redundancy is key, especially in terms of flight controls. But also the split rudders provide a finer high-speed control in that only the lower one moves at high speed, reducing the exposed surface area and therefore the control effect, as there is a structural benefit. By only using the lower rudder when the aircraft is at high speed, it reduces the twisting moment and transfers the load to a bigger, stronger part of the airframe. And that's the principle, is the same why the outboard ailerons are disabled at high speed. Now, as I said, the chances of multiple hydraulic system failures is very rare. Nevertheless, there was an incident in 2002 on a Boeing 747-400 which experienced a so-called lower rudder Hardover event. Now, the lower rudder suddenly went into the maximum deflection to the left, causing the plane to abruptly bank 30 to 40 degrees to the left. The pilots acted fast and applied full right rudder. Unfortunately, that was still not enough to prevent the plane from losing altitude, yawing and rolling to the left, so right aileron was also needed, and due to the limited controllability, the pilots immediately declared an emergency and landed at the next suitable airport, which FYI was 2 hours away. So for 2 hours the pilots were fighting with extreme forces on the control column, and with decreasing speed, the rudder authority of the slightly smaller upper rudder was not enough to fly the plane in a straight line. The pilots then used differential thrust to counteract the yawing moment on approach. The plane safely landed, and later investigation showed that the lower rudder control module had a broken housing due to metal fatigue, causing the Hardover. But for more details, read the NTSB report on Northwest Flight 85. Now you question, what about smaller jet airliners such as the Airbus A380 or the Boeing 737, which do not have a split rudder? Now on the Airbus A320, she has 3 hydraulic systems. The rudder is moved by 3 actuators, each individually powered, and as a backup, you have the hydraulic power transfer unit. As a second backup, the ram air turbine, and as a third, the mechanical connection. So the necessary redundancy is given. But please, may Boeing 737 pilots comment below on how their rudder redundancy is given, or just ask Dutch pilot girl. And the most unique split rudder you can find is on the B2 bomber. As she has no vertical stabilizer / rudder, she still needs to be controllable along the yaw axis. So the engineers placed these panels far out on her wing. They look like ailerons, which they are not, as the secret is on the lower side. Another panel on the lower side deflects downwards as the top one goes upwards, creating the necessary drag, forcing the plane to yaw to either side, making it the most unique split rudder for yaw control. And the panels you see here are the so-called ailerons for roll control of the plane. That is so clever. And if you now want to know why the rudder very often points to the right or left whilst the plane is parked at the gate, click onto the video link which will pop up here in a few seconds. And also check out my new t-shirt designs just above the description box. If you are a Boeing or Airbus lover, you definitely want to get one of my new shirts. That's it for today. Thank you very much for your time, and don't forget to hit that subscribe button and activate the notification bell so you won't miss out upcoming videos. And don't forget, a good pilot is always learning. See you next week. Wishing you all the best. Your Captain Joe.